tomorrow will be better. Why is the value of the acceleration due to gravity, g, the same for all bodies, irrespective of their masses? To start, dear friends, most of you are very familiar with the name gravitational acceleration or simply acceleration due to gravity. But how many of you also knew that this same quantity here is also called the gravitational field strength? With this, I would like to take you a little bit to some other place. Now, to explain this, let's start by recalling the origin of this gravitational acceleration. Follow me, dear friends. Solution. Like I said earlier, this could also be called the gravitational field strength. And this gravitational field strength, by definition, is equal to the force of gravity per unit mass. Now something else is coming up, the force of gravity. What is the force of gravity, dear friends? It is given by the gravitational field constant, the mass of whichever the source of the force, and the mass of the body on which the force is applied, divided by the square of the separation between the two bodies. Once more, let me remind you that for the case of the Earth, this will be the mass of the Earth. This will be the mass of whichever body you're considering, and then this will be the distance between the center of the Earth and the body in question. Now, gravitational field strength is this force per unit mass. So, gravitational field strength will be all of this here, big G, big M, small m, divided by r squared, further divided by small m. Why small m? Why can it not be big M? Because we know that the source of this force is from the Earth. So we cannot cancel big M. We are talking about small m here. So we are considering the mass of the body which is, or on which this attractive or attraction force is exerted. So if you do the division well, this is going to go away with this, and at the end you have that the gravitational field strength or the acceleration due to gravity will be equal to big G, the gravitational field constant, big M, the mass of the Earth, divided by the square of their separation. As you can see clearly in this final formula, the gravitational field strength or the acceleration due to gravity only depends on the mass of the Earth and the distance between the body in question and the center of the Earth. It has nothing to do with the mass of the body which we are considering. For this reason, whether it's a heavy object or it's a light object, as long as they are at the same altitude, r, the gravitational field strength or the acceleration due to gravity will have the same value. Tomorrow will be better.